Application in a Brownian motion. First of all, Brownian motion was discovered by the biologist Robert Brown in 1827. While Brown was studying pollen particle floating in water in the microscope, he was observed minute particles in the pollen grain executing the jittery motion. After repeating the experiment with a particle of dust, he was able to conclude that the motion was due to pollen being alive, but the origin of the motion remained unexplained. The first one to give the theory of a Brownian motion was Louis Bachelor in 1900 in his PhD thesis, which is the theory of a speculation. However, it was only in 1905 that Albert Einstein, using the probabilistic model, which is called, sufficiently explained the Brownian motion. He observed the model that the kinetic energy of fluid was right. The molecule of water moved at a random. Thus, a small particle would receive a random number of impact of the random strength from a random direction in any short period of time. This random bombardment by the molecule of the fluid would cause a sufficiently small particle to move exactly just how the Brown described. Application of the Brownian motion to the stock market. Since the mathematical theory of a Brownian motion has been applied in a context ranging far beyond the movement of a particle in a fluid, until recently stock market researchers have confronted the same problem. While they can chart the path of the market on a minute-by-minute basis, it is very hard for them to observe who buys, who sells, and how demand and supply affect the price of the movement. There exist many interesting theories about how the behavior of the different investors make the price move, but there is no empirical evidence to support the critical link between the investor decision and the price dynamic. However, stock market, the foreign exchange market, commodity market, and a bond market are all assumed to follow the Brownian motion, where assets are changing continually over a very small interval of time, and the position, namely the change of state of the asset, is being all altered by the random amount. The most importantly, the mathematical models was used to describe the Brownian motion, which is fundamental tools on which all financial asset pricing and derivative pricing models are based.
The first property of Brownian motion is independence of increments. Assuming difference percentage tend to be a reasonable assumption, at least on a reasonable long-term basis. Price increases are likely to be associated from second to second. Price increases are usually independent from day to day. Of course, predicting independent stock price change in the basis of what economists call the efficient market hypothesis or the random walk hypothesis, which we take as a given to apply basic probability theory.
Next property, normal increments. The presumption of a normal distribution, however, ignores the small possibility that a major negative shift may result from lower stock prices. Therefore, believing a continuous variation at different intervals of the same duration is not a good assumption, as the value of the stock itself tends to be unpredictable. That is, the volatility of a shift in stock price and need not be proportional to the time interval size.
The third property, which is the last property of the Brownian motion, is continuity of path. Continuity inference is a mathematical interpretation of the data gathered, but it makes sense. Securities trending second by second and minute by minute, so that prices jump by small amounts discretely. Examined on a day-to-day or week-to-week basis, the short-term shifts are small and rates tend to change constantly in contrast.